Welcome to the trig ratios and relationships formative review. This will help you do better on the formative and probably help you do better on the benchmark as well. Let's look at the first problem. So these problems were chosen to be similar to ones that you'll see on the formative or benchmark. So find the 6 trig ratios given the point 2, -3. So you can just, if you don't have graph paper handy, you can just draw yourself a coordinate plane. It might be easier on graph paper. You don't have to do as much drawing. All right, I'm going to need some values here since I just drew a little makeshift coordinate plane. And we're going to graph the point 2, -3. So I just put the lines in where I needed them. If you wanted, you could put them up here too. So 2, -3 is the fourth quadrant. It's where the x's are positive but the y's are negative. So 2, -3 is right here. All right, so there's the point 2, -3. All right, so now once you've got it graphed, remember to draw your reference triangle. And remember, it goes straight to the x-axis. That's where the right angle is located, and straight to the origin. So there's our reference triangle. As a little reminder, when you're setting these up, the x value is the adjacent side. The y value is the opposite side, always. My y looks like, I don't know, a weird U. And what about the hypotenuse? Well, the hypotenuse, which is also r, you can think of it one of two ways. You can think of it as the distance formula. So that means r would be the square root of the difference in the length of the x squared plus the length of y squared. So in other words, 2 squared plus, oops, excuse me, I wanted to keep it generic. X squared plus y squared. You could also think of it using Pythagorean theorem, right? This would just be the third side in a right triangle. So you can also think of it as r squared equals x squared plus y squared. Either works the same, right? Because if you take the square root of r squared, you'd get r. If you take the square root of x squared plus y squared, you get the square root of x squared plus y squared. So notice they're the same things. All right, so we have x, we have y, we need r. So r is, and I'll use this one, I guess. So r is equal to 2 squared plus -3 squared, especially because I started to write it that way anyway. So 2 squared is 4. Must have a glitch here. Look at those lines. And -3 squared is 9. That means r is the square root of 13. That's a prime number. It can't be simplified. But if we end up with a radical in the denominator, we'll make sure we rationalize. So I'm going to write this also on the triangle as well so we can see everything. So 2 is the adjacent side. And here would be theta, right? So this is the adjacent side. And remember, x is always the adjacent side. Opposite theta is -3. That's the y value. It is always the opposite side. And then square root of 13 is the hypotenuse. All right, so let's find our 6 trig ratios. So sine theta, which is opposite over hypotenuse, is going to be -3 over the square root of 13. We want to rationalize that, so we'll multiply by square root of 13 over square root of 13. So that would be negative square roots of 13 over square root of 13 times square root of 13 is the square root of 169. What's the square root of 169? Well, just 13. And you can just think about it as if you have the square root of 13 times 13, 1 comes out, 1 goes away. That's just 13, right? All right, let's find cosine theta, which is adjacent over hypotenuse. That'll be 2 over the square root of 13. And again, we'll need to rationalize that. So 2 square roots of 13 over 13. Tangent theta is opposite over adjacent. The opposite side is -3. Adjacent side is 2. And we're done with that one. Can't reduce that. And then cosecant is the reciprocal of sine, so it's hypotenuse over opposite. So that would be the square root of 13 over -3. Secant theta is the reciprocal of cosine, so it's going to be the hypotenuse over the adjacent. So that's just going to be the square root of 13 over 2. And then cotangent theta is adjacent over opposite. So that's going to be, so the adjacent side is 2 and the opposite is -3. It's the same as the reciprocal of tangent. And there we go. This one, that's all there is to finding any trig ratio given a point on the coordinate plane. Right? X is always your adjacent, y is always your opposite, and then use a distance formula or Pythagorean theorem to find the length of the hypotenuse. And just remember to reduce if possible and rationalize if there's a radical in the denominator. All right, so let's look at the quad angles. So a quad angle has the terminal side on the x-axis or y-axis. All right, let's go through the 4 quad angles. So we could be at 0 degrees. If we go all the way around the circle, that'd be 360. If we're working with radians, it's 0 or 2 pi. And actually, every time we go around the circle, it would be another 360 degrees or another 2 pi radians. Right, so this is equal to 90 degrees, so this would be a quarter turn. Actually, I'll color code this. So that would be a quarter turn, right? And that is 90 degrees. In radians, that's pi halves radians. If we go half a turn, that is 180 degrees, or pi radians. If we go 3/4, that is 270 degrees, or 3 pi halves radians. Right? So this is, we're going around the unit circle. The length, I wanted purple. I guess I can't have purple. There's purple. The length of our radius here is just 1. Right? So we have a radius of 1 going around a circle, and we want to evaluate. Right? So let's go through our opposite, our adjacent, and our hypotenuse. So remember that the opposite side, actually let's start with the adjacent side. The adjacent side is always x. The opposite side is always y. And the hypotenuse, which is known as r, is going to be 1. Right? We're on a unit circle with a radius of 1. So let's write down the values. Let's write down the point for each of these locations on the unit circle. So here we're going around the circle on a coordinate plane. Right? So that location on the coordinate plane is the point 1, 0. This location on the coordinate plane is the point 0, 1. This location on the coordinate plane is the point -1, 0. And this location on the coordinate plane is the point 0, -1. So for in every instance, the x value will be the adjacent, the y value will be the opposite, and no matter what, the hypotenuse is going to be 1. So now for each of these, let's write down the ratios. No, let's do the last one here. Oops, I'll have to write above. I don't have enough space below. And we're just going to write it in terms of radians. Right? That would be the same whether we wrote it in radians or degrees. All right, so we'll start with, and we'll skip 0. We'll start with pi halves, and then we'll do pi, 3 pi halves, and 2 pi. All right, so we have, and I have the sides that each of the trig ratios uses above. I almost forgot to say that. So sine theta, remember, uses the opposite over the hypotenuse. Its reciprocal is cosecant. That would be hypotenuse over opposite. Cosine theta is adjacent over hypotenuse. Its reciprocal is secant theta. That would be hypotenuse over adjacent. Tangent theta is opposite over adjacent, and its reciprocal is cotangent theta. That would be adjacent over opposite. All right, so we have sine pi halves. The opposite side is always y, so that's going to be 1. The hypotenuse is always 1. Right? So opposite is going to be y all the time. Adjacent is going to be x all the time. And the hypotenuse is always going to be 1. So that means sine pi halves is 1 over 1, which is just 1. Cosine pi halves is, so x is 0. So actually, no, let me write it next to these. So right next to here, I'm also going to write, this is y over r. This is r over y. This is x over r. This is r over x. This is x, excuse me. This is y over x. And this is x over r over y. All right, so there we have it written in terms of x, y, and r. Kind of helps us out on the unit circle. All right, so let's go back to what we were doing. So cosine pi halves would be x over r, so that would be 0 over 1, which is just 0. Tangent pi halves would be y over x, so that's going to be 1 over 0. That's undefined. Can't have 0 in a denominator. Cosecant pi halves, right, that's going to be r over y, so that's going to be 1 over 1, and that's 1. Secant pi halves is going to be r over x, so that's going to be 1 over 0, and that's undefined. Can't have 0 in a denominator. And then lastly, cotangent pi halves is x over y. That's 0 over 1. That's just 0. So interestingly, we had 2 values that were 1, 2 that were 0, and 2 that were undefined. Let's continue on, and now let's go to pi. Right? Again, adjacent is x. That's going to be -1. Opposite is y. That's going to be 0. And r is going to be, the hypotenuse is going to be 1. So we have sine pi is going to be y over r. So that's 0 over 1 or 0. Cosine pi is x over r. That's going to be -1 over 1. That's -1. Tangent pi is going to be y, which is 0, over x, which is 1. That's just 0. Cosecant pi is going to be r over y. So that's going to be 1 over 0. That's undefined. You can't divide by 0. Secant pi is going to be r over x. So that would be 1 over -1. And that's just -1. And then cotangent pi is going to be x, which is 1 over y, which is 0, and that is undefined. Notice that we have 2 0, 2 undefined, and now we have 2 -1, because that point there is -1, 0. Now we're at 3 pi halves. I may have to extend my page just a little bit. Oops, that's more than I wanted. We almost lost the unit circle. Yeah, I think that'll be fine. All right, so we have sine 3 pi halves, that's going to be y over r, so that's negative 1 over 1, that's negative 1. Cosine 3 pi halves is x over r, that's 0 over 1, that's a 0. Tangent 3 pi halves is y over x, that's negative 1 over 0, that's undefined. Cosecant 3 pi halves is r over y, that's negative 1 half. Excuse me, that's negative 1. There's no half. That's negative 1. Secant 3 pi halves is going to be r over x, that's 1 over 0, that's undefined. And if I can squeeze it in, cotangent 3 pi halves is going to be x over y, so that's 0 over 1, that's just 0, excuse me, 0 over negative 1, that's just 0. Okay, move that up just a little bit. I think we're losing the cotangent just a little bit. I'll write that again. That's 0 over negative 1, and that's just 0. So notice, again, we got 2 zeros, 2 undefineds, and 2 negative 1s. And lastly, let's find the trig ratios for 2 pi. All right, so we have sine 2 pi. All right, so sine is going to be y over r, so that's going to be 0 over 1, that's just 0. Cosine 2 pi, that's x over r, so that's going to be 1 over 1. Right? And you can tell what the x and y are, by the way, by the point. And the point is in the same color as the trig ratios. So everything for that location is the same color. And that's just 1. Tangent 2 pi is y over x, so that's 0 over 1, that's 0. Cosecant 2 pi, reciprocal of sine, that's going to be r over y, that's undefined. Secant 2 pi, that's going to be r, which is 1, over x, which is 1, that's 1. And cotangent 2 pi, that's going to be x, which is 1 over 0, and that's undefined. And notice we got 2 1s, 2 zeros, and 2 undefineds again. And actually that happens at all the quad angles, right? If you've got 0 in the, because our only values here is 0 and 1, right? So if you've got 0 in a numerator, you're 0. Oh, and we also have negative 1 if we're on the negative side of the graph. If you have 1 in a numerator and you've got 1 in the denominator, you're 1. If you've got a negative 1 in there, then you're negative 1. And if 0 is in the denominator, then you're undefined. Those are your only possibilities here. So here are all the trig ratios for the 4 quad angles. And by the way, 0 would be the same as 2 pi. Let's try the next one. Given that theta is negative 12/13 and cosine theta is 5/13, what quadrant does theta lie in? Now you can think of this one of 2 ways. You can think of the sides that sine uses. So sine, remember, is the opposite over the hypotenuse. The opposite is y. Hypotenuse is r. Cosine theta is adjacent over hypotenuse. That's x over r. R is always positive. X and y can be positive or negative. So notice that the adjacent side, which is 5, is positive. Well, where will x be positive? It'll be positive in the first quadrant, where x and y are positive, and it'll be positive in the 4th quadrant. I should probably label the quadrants. This is quadrant 1, quadrant 2, quadrant 3 and quadrant 4. Right? And it's x is positive in the fourth quadrant, where x is positive and y is negative. So cosine is going to be positive in the first quadrant, where all the trig functions are positive, and in the fourth quadrant, where only cosine and, of course, its reciprocal secant 2 are positive. All right, so now let's look at sine. All right, so if the sine is negative, that means that the opposite side is going to be negative. Right? So y is negative. Where is y negative? Well, y is negative in the third quadrant, where they're both negative, and in the fourth quadrant. So cosine is positive in the first and fourth. Sine is negative in the third and fourth. What do they have in common? The fourth quadrant. So, given that sine is negative and cosine is positive, what quadrant does theta lie in? Theta lies in quadrant 4. The other way you can remember is you can remember who's positive in each of the quadrants. They're all positive in the first quadrant. Sine, and of course, cosecant, its reciprocal, are positive. And in the third quadrant, only the two trig functions that use both negative values, which is tangent, and of course its reciprocal cotangent, are positive. All right, so you can remember it that way, or you can just think about the signs for x and y. All right? R is always positive. X and y can be positive or negative. X is always the adjacent side. Y is always the opposite side. All right? I think I have one more that looks at sine and figuring out what quadrant. In what quadrant is sine positive? All right, so this is kind of related to the question we just did. Remember, sine is positive wherever the y value is positive. All right, so that means that sine is going to be positive here, where both x and y are positive, and that's quadrant 1. Or here, where x is negative, but y is positive, and that's quadrant 2. So sine is positive where y is positive, that's quadrants 1 and 2. And not only is sine positive, so is cosecant. Right? If you want, we can also review, let's just review real quickly where the others are positive. Cosine is positive. Where x is positive. And so is secant. Right, because they're reciprocals of one another. So x is positive in the first quadrant, where they're all positive. X is also positive in the fourth quadrant, where the y is negative. So x is positive in that quadrant. So long as x is positive, cosine is positive, and so is secant. How about tangent and cotangent? Well, tangent is positive. Where x and y have the same sign. So that's going to be the first quadrant. I forgot to write down the answer for the last one. So cosine is positive, and its reciprocal secant is also positive in quadrants 1 and 4. And then lastly, tangent is positive where x and y have the same sign. That's either the first quadrant where they're both positive or the third quadrant where they're both negative. Right? So this is quadrants 1 and 3. All right, so now we've reviewed sign of all of our trig functions. All right, so I hope that's all clear for you. The last problem we're going to do is a very easy problem. It's coterminal angles. As a reminder, in radians, coterminal angles differ by 2 pi radians. So to find coterminal angles, add or subtract 2 pi. So let's find 2 angles that are coterminal to pi 6. Right? So number 1, pi 6 plus 2 pi. They would be coterminal. Now to add them together, let's change so they have a common denominator. So 2 pi is the same as 12 pi 6, right? 12 divided by 6 is 2. So that would be 13 pi 6. So that's our first coterminal angle. We could add another 2 pi, right? So if we wanted to add another 2 pi, that would be a coterminal angle. Actually, maybe we'll add, I'll do 3 coterminal angles. I'll do 2 positives. So if I were to add 2 pi twice, I would still have a coterminal angle, just a bigger one. So that would be the same as pi 6 plus 12 pi 6 plus 12 pi 6, which is going to be 25 pi 6. Or I could subtract 2 pi. Right? So I can keep adding 2 pi's or subtracting 2 pi's, and I will get coterminal angles every time. They're just either going around the circle again and landing in the same spot, or going the other direction and landing in the same spot. So pi 6 minus 2 pi is the same as pi 6 minus 12 pi 6. So a negative coterminal angle to pi 6 would be negative 11 pi 6. All right? And that's all there is on this particular video. All right? I hope you found this helpful, and good luck with your formative. Bye for now, and thanks for watching.